Okay guys, we are back and we are going to look at a few examples together, and then I'm going to give you a few to calculate and to create the scientific notation based on the standard numbers that you see on the board. Okay, so we have 263 million. We're going to write that in standard notation. We have 67,500. We'll write that in standard notation. And we have 1,500,000. We'll write that in standard notation. Remember the two steps that are required? First, write the number so that the decimal helps to depict that number from 1 to 10. And then multiply it by the power of 10 to create and recreate that same number you started with. All right, let's go. 263 million would look like this. We need to move our decimal 3, 6, 7, 8. It's going to look like 2.63 times 10 to the 3, 6, 7, 8 power. Okay? Why don't you check it? Use your calculator. Put in that decimal amount, 2.63 times 10 to the 8th power, and I bet you get the original number. Or you should. Okay? Let's look at 67,500. We're moving our decimal 1, 2, 3, 4 to get a number between 1 and 10, and that number is 6.75 times 10 to the 1, 2, 3, 4th power. Okay? That's what we call scientific notation. It makes the number easier to read and easier to understand. Let's look at now 1,500,000 would be 1.5 times 10 to the 3, 6 to the 6th power. All right, now it's your turn. We're going to be connecting science and math. Why don't you talk to your science teacher to let him or her, in our case, Mr. Marrow, know that you have been engaged in scientific notation. It's no wonder they call it scientific, because in science they're using humongous numbers. And we're going to look at a few right now. I see here Sirius A, the dog star, is the brightest star visible in the heavens. It has a mass of, oh my goodness, this number is in kilograms. Let me write it down for you. It is actually, let me put this as number 4, is actually 46,500, 000, let me count how many, 3, 6, 9, 12, 15, 18, 21, 24, 27 zeros. Can I even fit it here? 3, 6, 9, 12, 15, 16, 17. Woo! We just have to move this down. 3, 6, 9, 12, 15. Wow. 3, 6, 9, 12, 15, 18, 21, 24, 27. 3, 6, 9, 12, 15, 18, 21, 24, 7. Let's see if we got it. 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, that's how many zeros are attached to this number. And this is the mass of the brightest star that's able to be seen from the Earth. And this is also in kilograms. Okay? So how do we write such a humongous number? There's no way in the world I or Mr. Marrow or your science teacher could possibly read this number. And if we could, would we understand it? So, let's see. It's going to be 4.65 times 10 to the 30th power or to the 31st power? I wonder. Why don't you answer it? Is it to the 30th power? We'll make that A. Or is it B, 4.65 times 10 to the 31st power? Why don't you answer that? And we'll go on to the next one. This will be your exit ticket. To see if you understand how to write numbers in scientific notation. The nearest star beyond our sun is the very faint Proxima Centauri, which is, oh my goodness, let me write this number. 40, 300, 000, 000 kilometers from the sun. So, what is the answer here? Write this number in scientific notation. Remember, go up to where the digits are not zero and begin to work your number between 1 and 10. I'm not going to do this one, but you are. All right? I hope you've learned a lot about scientific notation. We will begin to work on smaller numbers real soon. These are the large, huge numbers and how to write scientific notation. All right? But we will be back with the smaller numbers and how to work with scientific notations when the numbers are very, very, very small. We'll be back.